And I told you in the last class that if you were to look at great societies wherein innovation is central, you see that this innovation engine keeps producing better and better innovations and products, and society continuously transforms. So you can see this change that is what has produced the American society, what has produced the Israeli society, what has produced the German society. And you will soon see, probably in today's class, how this innovation engine is working. And it is important to participate in that engine and that innovation. Then it becomes sort of perpetuates in the society. We will see all of these probably in today's lecture. I wanted to show you, in yesterday's class, I had talked about essentially one book. And I took some conclusions from a couple of other books. And I want to show you those books so that you can go back and read about, in case you are interested in more about this. By the way, I'm telling you something which is probably not what you're typically used to do, because there is a textbook and you go and read some page number X to page number whatever Y, and then answer a question. And this is not how these lectures are going to be. So it is going to be drawn from lots of insights, because there is no real textbook. So I told you about this book, which is asking this question: is knowledge thing or thought? And I essentially told you that when knowledge becomes thing, it becomes products. An example was the transmission electron microscope. And that thing then becomes, of course, a product, and it gets sold, and it becomes an institution, an organization, a company. So that innovation engine then transforms society, as I just told you about. And I took this example of thing knowledge to tell you that thing becomes an institution, a company. For example, thing that you see here, the electron microscope that I told you, essentially built Philips. And I'm not getting more into the details. The thing today, I told you about that thing, which is electron microscope, is a company called Thermo. And there are many Thermo microscopes here. And I told you that Thermo then subsequently, or microscope subsequently, produced carbon nanotubes. And that became graphene. And that, of course, gave one Nobel Prize. But then it created new knowledge, and it created subsequently economic returns, and society, of course, got benefited from that. So thing knowledge is central to this topic that we are talking about, of innovation becoming products, and the products transforming society. And why should you innovate? I told you that the central theme about to innovate in India especially, to address some large challenges. I told you about one of the biggest challenges why you innovate is inequality. And this is one small book which talks about how quality or inequality change society. There is a much larger version of this book called Capital, Capital of the 20th Century. But how do you address this inequality or problems such as population, or problems that I told you about sustainability. Those are the three larger things that are important to address by innovation. I gave you examples on using innovations, how can you address challenges of inequality? I gave you several examples, if you remember. And each one of them is probably several companies. Because how do you address inequality through education? There are many companies already existing. And you might innovate in a completely different way. I was in a digital university. There's a university, digital university, the first such digital university in India. I went there. So during COVID time, they introduced a product by which they wanted to teach people in Africa Indian percussion music. So there are very many Indian percussion instruments, and each one of them, those of you who have studied Carnatic music would know how difficult it is to learn one such instrument. And this is about that organization, Digital University, introducing a product during COVID time to introduce Carnatic percussion to African students. So there are many ways by which, now you might ask this question, how is it related to inequality? Well, we will come to that, how culture equates people. Culture removes barriers. So there are different discussions that we can have. The last bit that I wanted to tell you was that if you want to address equality, inequality through innovation, innovation is multidisciplinary. Innovation has no barriers between disciplines. So innovation talks about thinking in what is called systems. So we talk about changes in the whole system, not in civil engineering or mechanical engineering or chemistry, but in knowledge. So this is a book which introduced this concept of thinking in systems long, long ago, 2008. So since then, there have been lots of changes in this concept of thinking in systems. And this kind of a thought is today appreciated across biology, physics, engineering. It's not really that mechanical engineering that you need to innovate. You need to innovate in systems. So I leave this much and take some questions in case you have some questions. Otherwise, the wiring is complete, and so I can get to the topic. So Ramya, you can take some questions and then we can address them in the course of time.
Sir, one question.
Today,
I am
I
Sanjeev
wanted
Nistal.
to talk to you on innovation in a given branch of science and engineering. So yesterday there was this question, how do I innovate? I'm a mechanical engineer, how do I do? I'm a chemist, I'm a physicist, I'm a biologist, I'm an economist. How do I know? So there have been a number of examples of innovations in disciplines. So I took this book, and this book it came out in 2023. This is about chemistry entrepreneurship. Because I am a chemist, if you know, I'm a chemist, and therefore, for me, this is closer home. But I can talk also about physics entrepreneurship, or biology entrepreneurship, or genetics, or what have you. So if you look at a topic such as these, you ask this question, what is entrepreneurship in chemistry about? What is new that you can do today? So if you wish to ask that question, you need to ask this question, what is chemistry today? Or physics today? Chemistry today is $5 to $6 trillion, depending on how you calculate. Globally, I'm talking about global chemistry is $5 to $6 trillion. And that chemistry has a very important energy component, because the entire petroleum is chemistry. Now, pharmaceuticals is chemistry. Several other things are also chemistry. And therefore, chemistry is calculated in different buckets, so to say. So each one of these buckets you can innovate, and sub-buckets you can innovate. So, although I have written here, chemistry is such a big thing, 96% of the manufactured goods globally is chemistry goods. What you see is all chemistry goods. Of course, there is some electrical and there is some photonics or that. But what you're seeing here is chemistry. This is chemistry. So innovation is what you're seeing around this wall, for example. So all of these is that. So 96% of all the manufactured goods globally is chemistry, but chemistry is growing, but chemists are dying. You might say, I was just reading a New York Times article, that computer science is growing, but computer science scientists are not getting jobs now. Because artificial intelligence has sort of taken out all the coding. This today's news. So this can be said about every discipline. So how do you then innovate? How do you then produce this innovation to entrepreneurship, products, and then create economic value? So you innovate differently. So what am I saying here? The traditional innovation engine does not work. That is, if you wish to innovate in the way that you have been innovating, more steam engine. Well, steam engine is not possible, some other engine. That's not possible, some other engine is not going to work. So clothing, great clothing, but another clothing is needed. But a completely different innovation is required in clothing. So I have taken an example just to show you what does that mean. And that is, I took this particular example. It is the example of this company. This company is called Impossible Foods. What is Impossible Foods? Impossible Foods is a company which makes artificial meat. How about plant-based meat? How about beef, which is not beef, but tastes like beef? It has its nutrition like beef, but it is not cruelty. It reduces carbon dioxide. Well, meat, of course, as you know, consumes a whole lot of production, requires a whole lot of water. It requires a whole lot of energy. Grazing, methane, greenhouse warming. So if you start thinking about it, meat is a problem. So how do you address this problem? Somebody looked at this question at Stanford University. The professor, 2011, around 2008, he started asking this question, And his question was that, why is meat meat? Why does it give that particular kind of a taste? And he had a hunch that it is because of him. Meat is red meat. It is largely because of the taste is because of heme. Heme, as you know, you have studied in your high school. It's an iron compound, iron-containing protein. Is there a possibility that I can have a heme-containing plant? Well, there are plenty of plants. And they did this experiment and introduced artificial meat. From 2016, this is in the market. Of course, the company went through ups and downs and things like that, just as any company would go through. But the point that I'm trying to say, I was in Singapore a few years ago. I had a burger. It was a plant-based burger. So this is indeed possible. The innovation looks at a completely different domain. And of course, that innovation is connecting multiple dimensions of the society. You know, you are at one point in time, you're addressing cruelty. Well, through this very same innovation, you're addressing climate crisis. Through that, you are introducing water security. Along with that, you are probably introducing longevity. Many people think that plant-based life is probably more healthy. We are yet to know more about it. There's a whole lot of research going on in this direction. If you are a vegetarian, will you live longer? There have been experiments on this. So you are asking a question, going to ask a question, right? You will come to, we'll have plenty of time for this. So you can have a number of questions about this. Now, I wanted to introduce this thought that innovation today is different. It is asking a very different question. For example, can you grow food in factories? Do you need soil for agriculture? Or should you have agriculture at all? And they said, there is a friend of mine who is sucking CO2 from the air and giving you petrol. So it is innovation very different today. It is chemistry, or it is biology, or it is mechanical engineering, but it's very different today. And I showed you an example. So we will go further. Ramya, there is a question there. Please don't forget. So if you want to ask those questions, the central aspect of asking questions, we know, has been education. But then, how do you structure education to enable everybody innovators is a very recent thing. Structured education leading to innovation is more recent. So I want to tell you a brief story. You know, during the time of Second World War, so during Second World War, we had Roosevelt as the president. And Roosevelt, during his time, the great innovation of atom bomb happened. So this was under a great initiative wherein every possible form of military research was controlled by one person. The boss of that is there, Vannevar Bush. Vannevar Bush, after, of course, Hiroshima, Nagasaki, the Second World War was was over. And Roosevelt, as you know, had an accident, died, and his term ended. And the vice president, Truman, took over. And under Truman, whenever Bush was asked this question, what should we do to innovate? What should we do to make university system innovate? And this person, whenever Bush, wrote a book on that. And that book is this Science, the Endless Frontier. And it is through that book, American universities got transformed. And American Senate ruled that science, promoting science, is the responsibility of state. And because of this, NSF got formed. NSF, as you know, is National Science Foundation. And our IIT Madras, Indian Institute of Science alumnus was the director of that till recently. And another IIT Madras alumnus, Subra Suresh, was its director before, during Obama time. So NSF then started giving funding, and that funding resulted in Google. Translation as an important component, and NSF, like many institutions, came. NIH came in. It essentially looked at health-related innovation. And this resulted in a large number of technologies. And today, all that we talk about is a product of that. So if this book is a very short book, it is freely downloadable, and I would like you to have a look at this. So universities across the world followed this model of state funding of research. And today that is under great questions under Trump. But then this is the model that universities have followed. So organized research happened through creation of National Science Foundation and other such mechanisms. While this happened in 1945-46 period in America, and subsequent American change that you see, the American dollar, about 92 cents of that dollar comes from science. So this happened because of us. Because of this initiative to build it. So, is it that every kind of innovation became product? No, not really.
Hello.
Because is it possible to stop this destruction? Okay, if we can just move away if this is, okay. So every innovation did not translate to entrepreneurship and products. For example, this happened largely because research undervalued multiple steps of translation. So you may have an impossible food idea in the laboratory, or sitting right here, you may have an impossible food idea, but the impossible food will not get into marketplace. That is because research undervalued the steps involved in translation. So I took this example. This is a great invention, as you know, by Faraday. This was 1921, 27, 26, 27. 1830s. And now electrical engines started coming only by 1900s or so. And today this electrical engine is very big. These many gigawatts of power by 2020. None of these happened in universities. They all happened outside. And it's a very important point that I am trying to make here, that universities, of course, have undervalued. Universities have really not understood why or what are the steps involved in this translation. Of course, universities had great capacity to forecast. Around 1850, Faraday was asked this question: "Sir, great thing, great innovation. What is its use?" So this question was asked not by a small person. It was asked by the governor of the Reserve Bank, which UK said, Chancellor of the Exchequer. So Chancellor of the Exchequer asked this question to Faraday, and Faraday said, "Sir, one day you will tax it." So it is, universities had this great vision that what these innovations would do, but universities did not by themselves translate it, because they did not understood the reasons, and it went outside. So for this, I took an example. So here is this great person. Who is this? This is Haber. So Haber in 1908-9 period made this ammonia. It took quite some time for this to become an industry. It became an industry only because BASF took that patent. And because of the First World War, the great need for propellants made ammonium nitrate. It was very much needed. And because of which this particular thing happened. But the point is, it happened outside the university. And so today, this entire thing is because of that translation which just happened. So how does it happen, really? So today we have a model for it. So this model is, you have ideas. These ideas get to products, and these products then create value. And this value, going back to the society, it creates more institutions, and which create more ideas. So if this is the cycle of idea to product to value that universities have been proposing. And if you look at this in greater detail, idea to product is people, and these people are involved in institutions using equipment and appropriate funding. This is what state's responsibility was, as whenever Bush said. You put in an institution or on people money and resources, it produces ideas and products. This you take it to manufacturing through licensing, institutions, which are industries. They produce value. And of course, this value, a part of that value flows back into the universities. It creates, or it makes education possible. It changes society. More institutions come up. So this idea to product to value is the value chain of innovation. So each one of these is crucial, and this we will see in the course of time. How do you enhance each one of these? So if you look at this, this kind of a value chain, you operate under this value chain. If this value chain creates disturbance in the society, such as an environmental impact, for example, because this production produces, let us say, mercury in the water, this value chain is stopped. this innovation does not occur. Or you may say, in this particular thing, society is looking for sustainable development. If this is not possible, some fish is affected or something, or some monkeys are affected, of course, innovation value chain is stopped. So there can be 100 reasons why innovation can go wrong. But essentially, it is going from 1 to 3. Okay, so if you look at this 1 to 3 in greater detail, institutions have asked this question, how do I create a university, a mechanism wherein you create disruptive innovations? So to understand this, I've taken this particular diagram. So this is asking this question. Institutions traditionally wanted people to excel. Excel academically. What would be the great example of academic excellence? Bohr. Bohr. At one point in time, he was the Himalayas of physics. Well, institutions want excellence, but society wants what? Society wants solutions. So what would be the greatest example of solutions? Edison. So you have this and that as two independent expectations of institutions and society. But actually, what do you want? You want both. So who would be that great example of that? So this is Pasteur. Pasteur, as you know, the entire bacteriology came from Pasteur, Louis Pasteur and all. So institutions wanted to be in the Pasteur quadrant of institutional framework. So people have talked about Pasteur quadrant. How do we create Pasteur quadrant? And this is the reason we have a C5 there. Or this is why we have a research park there. This is why we have a course here. So you can ask many different questions around this. And these questions are all directing to Pasteur quadrant. And a related set. Well, this Pasteur quadrant, I'll show you a book on this, and you can read about this in greater detail. So if you translate this in an institutional, that institution, imagine it to be an industry. Industry is asking this question, well, I have this great product. And you're asking this question, is this commercially viable? Of course it is commercially viable. If something is commercially, let us say, non-viable, the product is certainly not going to be there. But commercial viability is not the only thing. It has to be made physically. Okay? It should be in a position to manufacture at hundreds and millions of times, reproducibly. Then only this is possible. So if this is commercially, it is possible, but physically it is just not possible, then product is not there in the market. Or it is physically, the product is always, it's the physical reality is possible. You can have a prototype in the laboratory. Prototype will never reach the market. The product will sit there in the lab, and across the world, such products have been plenty. And if you come to my lab, you will show that many products like this sitting there in the lab. But what is it we want? We want a product in the market should have a physical reality and should have a commercial viability. And this happens. This is greatly influenced by the time. Greatly influenced by the time. So you have to be there at that point in time, just as Moderna. So Moderna became a big hit, as you know. It became 89 billion market. A friend of mine had some shares of this, and he doesn't come to the university now. So there is no need. Now, but this is not just the story of Moderna. There are a number of therapeutics, CRISPR therapeutics, Intellia therapeutics, Editas, and CRISPR-Cas technologies, and a number of them have grown super fast. But along with that, you also have a number of failures. Universities thought that technologies could come super fast, and several people started companies. An example is Theranos, which said that one drop of blood, you can get everything from that blood. Of course, it might be possible in some years later, but this technology, what was said by Theranos was wrong, and the technology turned out to be, or the company went bankrupt. But I just told you about science-based innovations solving societal problems by fundamental research. By understanding science, like Ziegler-Natta catalyst catalysis you might have heard about. It is how an organometallic catalyst can do polymerization affordably. That made polyethylene possible. It's a great product. This happened because of fundamental research. But the time needed for fundamental research to get to the marketplace is very, very long. While bits become bytes and megabytes and gigabytes super fast, molecules don't grow like that. What I wanted to tell you is that fundamental research is always very slow. It takes 5 years or 10 years or 15 years for a product to be in the marketplace. For example, in medicine, it could be 12 years. Now you will soon see when you go to Bangalore, how the NCBS companies are taking product and idea to market, but well, taking time. You will also see technologies which are maturing super fast, but in a completely different domain. Science requires endurance. And for that, I have this slide to tell you. This will be probably my last slide. A company called Microsoft was founded in 1975. And 1975, Microsoft today has a market capitalization of about $3.9 trillion. But a company which was formed in 1865, this is just 50 years, right? 1865, which is the world's largest chemical company, BASF, its market value is just 3.4 trillion. So molecules don't grow that fast. Okay. So it's very important to realize that deep tech, in high tech, with deep understanding, it's very difficult for them to grow super fast. But then deep tech can get great things done because deep tech can change the society. So you ask this question, what do you love? And that's what makes your innovation ticking. With that, I'll take questions. So broadly speaking, what we saw today was innovation is not essential for science and scientists and engineers. Innovation became the cornerstone of institutions after Vannevar Bush's suggestion of science, the endless frontier, which created institutions. These institutions created an innovation model, and that is going from 1 to 3 that I just told you about. And there are many factors which control this 1 to 2, and 2 to 3, and 3 to 1 translation impossible because of multiple factors. And if you run this well, many institutions have created mechanisms such as the C5 I mentioned to run this efficiently. And if you do that, of course, innovation becomes possible. However, molecules are not bits. Okay, so this is what I said essentially in summary, and I will take questions.
We'll first go for in-class questions.
Hello. Should I stand up?
Yeah, you can, so that the camera can focus on you.
Oh,
Yeah,
okay.
sure. Because we don't have 2 cameras. The other one had 2 cameras.
Yeah, sure, no issues.
Yeah.
What I wanted to ask, you showed a website of Impossible Food.
Yeah.
Why would anyone like to eat that? Like, if a vegetarian won't like beef, so why would he taste beef? And a non-veg would not ever replace his taste with some plant-grown thing.
Yeah, good,
Yeah.
fantastic question. So, but then, so that is the preconceived notion that non-vegetarian or chicken or beef is unreplaceable. This is completely wrong because we know genetically modified thing, lab-grown food has been tested. With similar tastes, similar price points, similar nutrition, it will hit the market. But I must tell you, what will not hit the market, this may not hit the market, not because of any of the reasons that technology is not possible, etc. Wheat cannot be made, etc. It's because of the price point. You may not be in a position to deliver fish, impossible fish, at the fish cost. Impossible meat at the meat cost. That is where today's, not just this alone. Yesterday I talked about Oho skin. Oho skin is great skin, but it may not hit the market because leather is available at a much lower price. So what are you willing to sacrifice for your ethical concern? Are you going to shell out more money? It will essentially come to that. So it is another aspect that we need to address. So for example, at some point in time, somebody was telling me, why should in India washing machines be sold? Washing machine is 25,000 rupees, 20,000 rupees, 15,000 rupees. And I have to do this myself. But with 200 rupees, I can get a dhobi. 200 into whatever number of times that you do, it's not going to become, it will become 15,000 rupees only after many years. So it's not possible. But it so happened that India went along the washing machines direction. So I can take many examples like this to tell you that what determines principally is price. Okay, we'll take.
We have Khalil Ahmed in another class.
Yeah.
Are there frameworks for spotting problems in our daily work that could become business opportunities?
Absolutely. There are plenty of business opportunities that we will soon see. Probably 2-3 more classes to go to notice this. For example, right now, in this room, I'm having a slightly lower temperature that I would have liked a slightly warmer temperature. Slightly, being a Drazi, a slightly warmer temperature. But some of you might be very comfortable. So I'm talking about something personalized here. So can I have a personalized device on me? A cream, something? So this is certainly a great thing for, let us say, imagine you are in an opera. No, everyone does not like this particular temperature. You want personalized atmosphere. So spotting opportunities is essentially sitting in the right place with the right training. Impossible Food itself came because of such a great experience by its founder. So that is why it is important to read about these things, how this happened really. What itched this fellow? Okay, what's the next one?
Parthasarthi is asking, can we say the equivalent in jewelry, as in for lab-grown diamonds,
Absolutely.
compared with the impossible meat?
Absolutely. There are plenty of examples. For example, somebody wants to convert. There is a company which is making parents into diamonds. Pretty sad. That is, your parent is gone, dead. So you have carbon, and you make the carbon into diamond and wear the parent. So all that you have to do is send the ashes, and it will get you a diamond. Is that a business model? Yes, it is a business model. It's a working company, I'm telling you. Okay.
Mathuri is asking, why molecules are not increasing fast? They have smart in the globe than deep tech.
Molecules are serial, you see. Molecules are serial, one chemical bond at a time. And it has its complications. You twist the chemical bond differently, the molecule is different. So it's extremely serial, and it has a number of degrees of freedom. Each one has to be controlled to do chemistry right. So molecules certainly have more flexibility. That's why, chemical engineers will tell you process engineering. Process engineering is very complex. If you don't engineer the process correctly, you will not have the right polymer or petroleum or whatever. Okay.
Amar Gupta is asking, what kind of innovations make sense to transform the farmer to consumer model? Is it actually possible considering the supply chain issues we see globally?
I think we should take this off right now, and we should discuss this. It will take a little more time. Yeah. So with that, probably we'll come to an end for today's questions.